like to do an application of something that happened in my son's middle school. So he had a friend named Clayton who was selling candy in the schoolyard, which was totally illegal. And each bag of candy cost $3, and he charged 25 cents per candy that he sold. The profit function could be expressed by the formula P of x is equal to 0.25x minus 3, where P of x is the profit and x is the number of candies sold. So the first question asks, find the profit of selling 40 candies, and we can write out this expression, the profit of selling 40 candies, but the shortcut way of writing this is to say that P means profit, so we can write this, the profit of 40 candies, in this abbreviated way. And this is one of the reasons for writing things in function notation, to make it short and simple. So we've got P of 40, profit of 40, is equal to 0.25 times x, which in this case we've let equal to 40, minus 3. So we simplify this. 0.25 is a quarter. A quarter of 40 is equal to 10, minus 3, and that gives us 7. And so if we interpret this, it means that the profit of selling 40 candies is $7. He takes $10 in revenue in from 25 cents per candy and 40 candies in the bag, but he had to spend $3 in order to purchase the bag. The second question asks, find P of 0. So P of 0 means plug the number 0 into the equation. So we get 0.25 times 0 minus 3, and then that gives us negative 3. And when we interpret this, P of 0, or profit of 0 candies sold, is negative 3. That means that he loses $3 if he doesn't sell any candy because he spent $3 on the bag. So we can write this as the profit of 0 candies sold is equal to negative 3, which is essentially a $3 loss. Next, we're asked to find the break-even point, and break-even means that no money is lost and no money is gained. And so the profit, P of x, is going to be equal to 0. And if we go back to the equation, letting P of x equal 0, we have then that 0 is equal to 0.25x minus 3. And now we want to solve this for x, so we'll add 3 to both sides. We get 3 is equal to 0.25x, and again, solving for x, we divide by 0.25, that is, divide by a quarter. So we end up with that x is equal to 12. And if we interpret that, we see that x is equal to 12 means 12 candies sold will result in 0 profit. So for 25 cents times the 12 candies, we make $3, and that offsets or compensates for the $3 spent on the bag. The last part of the problem asks us to graph the function, and so we have our two axes. We have our P of x axis and our x axis. And our profit, or P of x, we can see that it spans between negative $3 and positive $7, so I'm going to draw a little bit further down here for the negative. Let's make this negative 5, and then we go to 0, and then positive 5 and positive 10. Next, to draw our hatch marks for our x-axis, we note that the x values go between 0 and 40. And I'm going to truncate this scale. It doesn't have to be identical to the other scale, but I will do increments of 10 so that we get up to 40. And when x is equal to 40, the profit is equal to positive 7. So here is our value of 40, and here's positive 7. When x is equal to 0, our y value is at negative 3 down here. And then at the break-even point, when x is equal to 12, so we can write this as the ordered pair 12, 0, and 12 over here, it's a little bit past 10, and our y value is 0 at that point. So we can see from these 3 points that we do have a linear equation, and we can connect the dots and draw the graph for this particular function.